students, this is Indrani ma'am. Welcome back to SIP Rasayan. In this video we will study what is functional group and nomenclature of organic compounds. So what is the definition of functional group? The functional group may be defined as an atom or group of atoms joined in a specific manner which mostly determines the characteristic chemical properties of the organic compounds. Here are some functional group and here is the name of the family of compound. Suppose, now see, first you see here, functional group may contain one atom like ether, and or functional group may contain different atoms but they are joined in a specific manner. Suppose in aldehyde, carbon is bonded with hydrogen and carbon is also bonded with one oxygen. One double bond is there between these two. So in a specific manner, all atoms are joined to form a functional group. And the chemical properties depend on the functional group present in a compound. Now see, this is called, if OH is present, it is called hydroxyl group, and family of compounds, it is called alcohol. Compounds which are having OH functional group, they are having similar chemical properties. Similarly, this is CHO, aldehyde group. Family of compounds is called aldehydes. This is carboxylic acid, COOH. It is called family of compounds, carboxylic acids. Carboxylic acids you can write like this way also. Okay. Now this is ketone, CO, and family of compounds is called ketones. And here it is amino group, NH2. Family of compounds is amines. This is ether and family of compounds is ethers. Next is nomenclature of organic compounds. Now see, millions of organic compounds are there. So for clearly identify them, a systematic method of naming has been developed and it is known as IUPAC, or you can say IUPAC, System of Nomenclature. International Union of Pure and Applied Chemistry. Once again, International Union of Pure and Applied Chemistry. Before the IUPAC System of Nomenclature, names of the organic compounds were given based on their origin or certain properties. As for example, urea, you know the name of the compound urea. Urea was so named because it was found from urine of mammals. Urine of mammals. Citric acid is named so because it is found in citrus fruits. In citrus fruits. HCOOH. This is called formic acid. Why it is called formic acid? Since it is found in red ant. And in Latin, red ant is called formica. So from formica, name is formic acid. These names of organic compounds were called, trivial or common name. Common names are indispensable when the alternative systematic names are lengthy and complicated. Now see, you will study all those compounds. This is C2H4. In IUPAC you will see it is called ethene, but its common name is ethylene. And its very famous name, ethylene. Another thing, this molecule C2H2, it is called IUPAC name ethine. We will study all those, and its common name, very famous, acetylene. Now see, according to IUPAC system of nomenclature, the name of organic compound contains three parts. One is prefix, another is word root, another is suffix. Before word root, what you have to write, it is called prefix, and after word root, what you have to write is called suffix. Then first we should know what is word root. It indicates the number of carbon atoms present in parent chain or principal chain. Once again, it indicates the number of carbon atoms present in parent chain or principal chain. What is principal chain? So, it is the longest possible chain of carbon atoms. Once again, it is the longest possible chain of carbon atoms. It is called principal chain or parent chain. For example, in this compound, which is the longest possible chain? If you count 1, 2, 3, 4, 5, 6, 6 carbon atoms are there in this chain. Here 1, 2, 3, 4, 5. 5 carbons are there in this chain. 1, 2, 3, 4 carbon atoms are there. So longest possible chain of carbon atoms here is this one. And this is called your principal chain or parent chain. Now see here, I have written number of carbons in parent chain, and what word root you have to write for that, it is given here. So if in your parent chain 1 carbon is there, you have to use which word root? Meth, METH. For 2 carbon atoms, eth, ETH. For 3, prop. For 4 carbon atoms, but. For 5 carbon, pent. For 6 carbons, hex. For 7 carbon, hept. For 8, oct. For 9 carbon, non. For 10 carbons, dec. For 11 carbons, undec. For 12 carbons, dodec. All those word roots you have to use if your parent chain or principal chain is containing this number of carbon atoms. Now we should know about prefix. Prefix comes before the word root. Two types of prefixes are there. One is secondary prefix. In any compound, if any substituent is there, it has to be mentioned as secondary prefix. If you are having fluorine as substituent, you have to use secondary prefix as fluoro. For chlorine as substituent, you have to write chloro. For bromine, you have to write bromo. For iodine, you have to write iodo. For NO, you have to write nitroso. NO2, you have to write nitro. And for any alkyl group means this one. If you are having CH3, you have to write methyl. If you are having C2H5, you have to write ethyl. And for alkoxy, this is alkoxy. Suppose you are having OCH3, you have to write methoxy. OC2H5, you have to write ethoxy as secondary prefix. So we have seen prefixes are of two types. One is secondary prefix, another is primary prefix. What is primary prefix? For cyclic compounds, you have to write cyclo. For example, if you are having this one, three carbon atoms, so propane, and it is cyclic, so you have to add cyclo as prefix, then cyclopropane. cyclobutane if 4-membered ring is there. So this is called primary prefix. Now we should know what is suffix. Suffix comes after the word root. Two types of suffixes are there. One is primary suffix. If in your compound only carbon-carbon single bond is there, carbon-carbon single bond is there, means this one it is there. So just after word root you have to add N. Means if you are having this one, only carbon-carbon single bond, no double bond, no triple bond, nothing is there. So for two carbon chains you have to write word root eth plus N you have to add as suffix, primary suffix. So it will be only ethane. If it is this one, so meth plus N, methane. Now see, if in the parent chain you are having carbon-carbon double bond, so after word root you have to add in, E-N-E, in. So suppose you are having this structure, three carbon atoms are there, so pro word root plus double bond is there in the main chain, so pro plus in. It is coming, this is suffix, propene. Now if in the main chain or principal chain carbon-carbon triple bond is there, after word root you have to add Y-N-E, ine. So if this is your compound, here three carbon atoms, so pro plus ine, means you have to write the name propine. If in the principal chain 4 carbon atoms are there, we are using but. But here 2 double bonds are there, so we have to add here buta. If 2 double bonds are there, you add buta plus double bond means E-N-E, in, 2 double bonds are there, so diene. Means your name will be butadiene. Now we should know about secondary suffix. This is primary suffix, this is secondary suffix. If functional group is present in organic compound, then it has to be written after the primary suffix. Later I will explain about functional group. Now see how to write the name of IUPAC, name of organic compound. First you have to mention secondary prefix, then primary prefix, then word root, then primary suffix, then secondary suffix. So secondary prefix means which one? Substituent. Primary prefix means if your compound is cyclic, you have to write cyclo. Word root means number of carbon atoms in principal or parent chain. Then primary suffix means en, in or ine. And secondary suffix means if functional group is present, that one you have to mention. Once again, secondary prefix plus primary prefix plus word root plus primary suffix plus secondary suffix. Now we should know what is hydrocarbon. Compounds containing carbon and hydrogen only are called hydrocarbons. Once again, compounds containing carbon and hydrogen only are called hydrocarbons. You can classify hydrocarbon as two types of hydrocarbons are there. One is saturated, another is unsaturated hydrocarbon. For saturated hydrocarbon, see, it contains only carbon-carbon single bond. These are called alkane. These are also called paraffins. These are also called paraffins because these are little reactive towards the chemical reactions. General formula of saturated hydrocarbon is CnH2n plus 2. Okay. Now what is unsaturated hydrocarbon? Unsaturated hydrocarbons are those which contain at least one carbon-carbon double or triple bond. Examples: ethene, ethyne, propene. In ethene and propene double bond is there, in ethyne triple bond is there. So all those are unsaturated hydrocarbons. Why hydrocarbons? These are made up of carbon and hydrogen only. And why unsaturated? Because these are having double and triple bonds. Now we will study what are the types of carbon atoms in alkanes. 4 types of carbon atoms are there. This is called 1 degree means primary. This is 2 degree means secondary. This is 3 degree. That means tertiary. And this is 4 degree means quaternary. So this is 1 degree means primary, 2 degree means secondary, 3 degree means tertiary and 4 degree means quaternary carbon. Now what is 1 degree or primary carbon? A carbon atom attached to one or no carbon atoms is called primary carbon. Now see in methane, CH4, with this carbon, no carbon is attached, only hydrogens are attached. So this is 1 degree carbon. And in ethane molecule, I am writing the complete structure, okay. See, this carbon is attached with one carbon, this carbon is also attached with one carbon. So all these 2 carbons are also 1 degree each. This is 1 degree, this carbon is also 1 degree. Now what is secondary or 2 degree carbon? A carbon atom attached to 2 carbon atoms is called secondary carbon. What is tertiary carbon or 3 degree? A carbon atom attached to 3 carbon atoms is called tertiary or 3 degree carbon. And what is quaternary or 4 degree carbon? A carbon atom attached to 4 carbon atoms is called quaternary or 4 degree carbon. Now remember, the hydrogen atoms attached to 1 degree, 2 degree, 3 degree carbon atoms are called 1 degree, 2 degree, 3 degree hydrogen atoms respectively. And for quaternary carbon, no hydrogen atom is attached there. Hydrocarbons are broadly classified as saturated and unsaturated hydrocarbons. We have seen already. Under saturated hydrocarbon, 2 types are there. One is straight chain, another is branch chain hydrocarbon. So first we will study IUPAC naming of some unbranched means straight chain saturated hydrocarbons. Now see here, it is MF means molecular formula, word root, primary suffix and name. In these compounds, no unsaturation is there. These are saturated hydrocarbons means alkane. All are having general formula CnH2n plus 2. You can check. Okay. For methane, this carbon N is equal to 1. Therefore, CH, if N is equal to 1, it is 4. So here word root is meth, suffix N. So meth plus N is equal to methane. Similarly, for 2 carbon atoms, eth plus N, ethane. 3 carbon atoms, prop plus N, propane. 4 carbon atoms, but plus N, butane. 5 carbon atoms, pent plus N, pentane. For 6 carbon atoms, hex plus N, hexane. For 7 carbon atoms, hept plus N, heptane. Now please note, Word root indicates the number of carbon atoms present in the parent chain or principal chain or main chain. But for the chain having up to 4 carbon atoms, special word roots are used, which are related to their trivial or common name. For 8 carbon atoms, word root oct suffix n, so octane. For 9 carbon atoms, non plus n, nonen. For 10 carbon atoms, dec plus n, decane. Similarly, it will go. Okay, now if it is having, alkane is having 20 carbon atoms, it is called icosane. And if it is having 30 carbon atoms, then it is called tricontane. So you need mostly up to 10 carbon atoms. Now branch chain hydrocarbon. In a branch chain compound, small chains of carbon atoms are attached at one or more than one carbon atoms, at one or more than one carbon atoms of the principal or parent chain. Suppose this is principal or parent chain. So if here one carbon atom is present, here 2 carbon atoms are present, so these are called branching. Okay. The small chain of carbon atoms or branches are called alkyl group. So this one, these are called alkyl groups. They are having small chain of carbon atoms than the principal or parent chain. See, alkane we are representing like RH. So removal of one hydrogen is giving this one. This is called alkyl group. General representation. And this is your alkane. Now see, from one alkane, how many types of alkyl group can generate? It depends on how many different types of carbon atoms are present in the molecule. Now see, in ethane molecule, this is ethane, CH3, CH3. This carbon is attached with one carbon, this carbon is attached with also one carbon. So this is primary carbon, this carbon is primary carbon. So both the carbon atoms are primary, so only one alkyl group can be formed. So only one alkyl group can be formed. Means by removal of hydrogen, you will get this one, CH3, CH2. And how you will get the name? In place of N, you have to write YL. In place of N, ANE, you have to write YL. So the name of the alkyl group will be ethyl. It is ethyl. Okay. Now see, for propane. Oh, another thing, ethyl, you can represent it like that way, ET abbreviation, or you can write it as C2H5. So there are many ways of representation. Now for propane, consider the structure of propane, CH3, CH2, CH3. These two carbons, terminal carbons, are primary carbon. But this carbon is attached with two other carbons, so it is secondary carbon. So you can understand two different types of carbons are there. So two different alkyl group can generate by removal of hydrogen from propane. By removal of hydrogen from 1 degree carbon, we are getting, so from here we are removing one hydrogen, or from here we are removing one hydrogen, we are getting CH3, CH2, CH2. One open valence is there because carbon is tetravalent, so 1, 2, 3 and it will be attached to something. So this group is called N-propyl group. And if hydrogen is removed from secondary carbon, so here we will get CH3, CH, CH3 and here one open valency. Means it will be attached with something to make it, to fulfill its tetravalency. It is called isopropyl group. And abbreviation of propyl group is this one. Propyl group is, here I am writing PR for propyl. propyl group. For ethyl we are writing Et, and for propyl group we are writing Pr. So how we are getting the name propyl? Prop plus in place of ANE we are writing YL. So propyl. Now mind it, this N-propyl, isopropyl all are common name or trivial name. Now see, CH3, CH2, CH2, CH3. This is normal butane. So here two types of carbons are there. These two carbons are 1 degree and these two carbons are 2 degree. So removal of one hydrogen from 1 degree carbon is giving CH3, CH2, CH2, CH2. This is known as N-butyl group. In place of N, we are writing YL. Okay. Since one hydrogen is removed here, so one open valency is there because it should be attached with the main chain. And here valency of carbon, tetravalency of carbon should be satisfied. Now see, removal of one hydrogen from these positions, either from any carbon, is giving CH3, CH, CH2, CH3. This is called secondary butyl group. Similarly, CH3, CH, CH3, CH3. This is your isobutane. It is having, here this is 1 degree carbon, this is 1 degree, this is 1 degree, but this one is attached with 3 carbon atoms, so it is 3 degree, means tertiary carbon. So removal of one hydrogen from 1 degree carbon is giving CH3, CH, others will be as it is. Here only we are removing from here one hydrogen. So this is known as isobutyl group. Isobutyl group. And removal of one hydrogen from tertiary carbon is giving CH3, C, CH3, CH3. Here one bond is giving tertiary butyl. So all those are common name or trivial name. Similarly, for 5 carbon atoms, CH3, CCH3, CH3, CH2. This is called neopentyl. This is also very important. So today till this, next part will be in the next video. Thank you for watching.